everyone. My name is Samandra son of Rajan and my matrix number is 15DEP25F1009. Welcome to my presentation for the course DEE20143 Semiconductor Devices. Today for our GSA2 assessment, I will be presenting topic 3, the bipolar junction transistor. Begin with question 1. What components and equipments do we need? To build a standard BJT common emitter circuit, we need one transistor, 4 biasing resistor, 3 capacitor, and a DC power supply to amplify our AC input signal. B. What is the main job of the BJT here? The primary function of the BJT in the circuit is to act as the main amplifier. It takes a weak signal and boosts it so it can be used by other parts as a larger system. Question C. What instruments is used to observe the value of voltage and currents? To actually observe what is happening in our circuit, we rely on two main instruments. Is multimeter. This is the primary tool used to measure exact numerical values. You can set it to act as a voltmeter to measure voltage or an ammeter to measure current. Another one is oscilloscope. While a multimeter gives you a single number, an oscilloscope lets you visually observe the signal. It shows you a graph how the AC voltage changes over time, which is essential for seeing if your BJT is amplifying the wave correctly. Question 2. How is this circuit actually connected? As you can see in the diagram, the setup revolves around the three main pins of the transistor. The base is our input. This is where the small AC signal that needs to amplify is connected. The collector is our output. The amplified signal is taken directly from this terminal. Finally, the emitter common. This terminal connects to the ground, usually through a resistor, making it the shared return path for both the input and output circuits. 3. Operation of BJT common emitter configuration. Now for question 3, how does it actually operate? I like to break this down into 5 simple steps. First, the setup. The DC power supply acts like a main water pipe. It provides a steady flow of power so the transistor is awake and ready to work. Second, the small input. Your tiny AC input signal, like a whisper into a microphone, enters the base of the transistor. Third, the valve effect. Think of the transistor as a super sensitive valve. That tiny input signal opens and closes the valve, which controls the massive flow of current from the main power supply. Fourth, the big output. Because a huge amount of current is now controlled by a tiny signal, it creates a much larger amplified voltage at the collector output. Fifth, the flip. The only catch is that the output signal is inverted. When your input wave goes up, the output wave goes down. It's much bigger but upside down. Question 4. Safety when building and testing this circuit in this lab. Always remember these 5 rules. First, power off first. Always build or modify your circuit with power supply completely turned off. Second, check the pins. Double check your transistor pins and the positive and negative sides of your capacitors. Plugging them in backwards can damage or even pop them. Third, avoid short circuits. Make sure exposed wires and components legs on your breadboard aren't accidentally touching each other. Fourth, verify instrument settings. Always make sure your multimeter or oscilloscope is on the correct setting before you touch the probes to the circuit. And lastly, don't overpower. Keep the DC power supply voltage within the safe limit of your specific transistor so it doesn't overheat and burn out. That's all from me. Thank you for listening to my presentation.